Okay, for our final question in this test series, we have a sector OPQ circle radius R and has a 100 area of 100 centimeters. When to show that the perimeter of the sector is equal to 2R plus 200 over R centimeters. So what we need to do is use these formulae that are given to us on the formula sheet. So we know the length of the arc L, this length, is equal to R theta, and we know the area of a sector equals a half R square theta. And using those, we know that as an area of 100 centimeters, so therefore we're going to put 100 equals a half R squared theta. Now, as there's no thetas in the formula here, we need to find out what theta is in terms of R. The theta will equal 200 divided by R squared. Now, for the perimeter, we've got R plus R, so it's going to be equal to 2R. And then we've got this length here, which is R theta. But we know that theta equals 200 over R squared. So our perimeter will equal 2R plus R times 200 over R squared. So therefore, P will equal 2R plus one of these R's is going to cancel here to leave us just 200 over R. Now, next it says deduce the value of R for which the perimeter is a minimum. Now, you could differentiate this, put it equal to 0 and solve the equation. Or alternatively, you can just go straight into here. Just delete this old function. Type this function in. So we're going to do 2x plus fraction 200 over x, because we've got to use x on our calculator. So we use y and x instead of p and r. Press execute. Let's draw that. And it doesn't appear on our thing. Now, given that the area is 100, it's unlike centimeters squared. It's unlikely that the radius is going to be much more than 10. So let's just do a quick change of the view window. So we've got x min to x max. It's probably, well, the y value, remember, is the area. So let's just make this more, go up to, which is not its area, it's our perimeter. It's definitely not going to be probably more than 100. Let's have a look at that. Let's scale that down to 50. Control that. And we got a curve going on there. So what we wanted to do, we wanted to find the minimum. So let's do graph solve min. And it's not found. So I've obviously not gone far enough in my range. So let's go view window. Let's just make my x value go up to, say, 25. Control that. And we see we now got a minimum. I had a feeling we didn't have the minimum quite on the graph. So graph solve, min, and it tells us it happens that x equals 10 and the perimeter equals 40. So therefore, part 2, r equals 10 when p equals 40 is a minimum. Okay, and that's all you need to do to actually answer that question. Right, what I'm going to do is just show you how you can do this if it does ask you to use calculus to solve this problem. So we know that P equals 2R plus 200 over R. But we're going to differentiate this. I'm just going to use the dash notation for the derivative. Differentiate 2R, I get 2. Differentiate 200 over R. Well, that's just the same as 200 R to the minus 1. So I'm going to times by minus 1. So I'm going to get minus 200. I get R to, I take 1 off the power, I get minus 2. Now we're going to make P dash equal 0 because that's where max and mins happen. So I'm going to write this as a fraction, like R squared instead of R to minus 2. Then I get 200 over R squared will equal 2. So 200 equals 2R squared. So 100 must equal R squared, which implies that R equals 10. And you can see we've got exactly the same answer we had before. We can take that R equals 10, put it back into here. 2 times 10 is 20. 200 divided by 10 is another 20. And together you get 40. And we found our P. If we do P double dash, we get, what we're going to get, minus 2. The 2 is going to go. Minus 2 times minus 200 is 400. R to minus 3. If you put 10 into this, you'll get a positive number. So therefore, P double dash is greater than 0, and therefore we have a min. So we can even prove we've got a minimum using the second derivative. And that's what you can do if the question asked you to do all the calculus as well.